What's up guys, welcome back. My name is Gunnar and in this video I'm going to talk about the future plans of my laser cutter in attempt to finish it somewhat more completely. I'm gonna go through my machine step by step and talk about what kind of ideas I have in mind for permanently finishing this machine. I did this once before, hence the introduction video and this BuildLog series. And now I'm planning on taking the machine apart a third and last time. Before I do that though, I want to have a clear plan on how I'm going to make that happen. Now, I'm guessing here, but if you're watching this video, the chances are that you're considering buying or building a laser cutter, or maybe already have one and in search for inspiration from others, as I often do that myself. Well, this time I might need some help from you guys deciding some stuff. So if you think something is a good or a bad idea, whether there's something I'm missing, or you have a complete other suggestion, please comment down below as I want to consider all my options before starting this final build update. So here's what I'm considering, and be warned, as this is a longer video with lots of me babbling on, feel free to jump to a certain section as I've added timeline chapters in the description below. Let's get to it. Now when it comes to making things manually, I am no expert and my skills are definitely lacking. However, I do firmly believe that you've got to have the right tool for the job. So I have expanded the workshop with a couple of them. Like this bandsaw for instance, which I'm pretty excited about to be honest. This metal bandsaw for cutting profiles more accurately. And last but not least, this manual sheet bender, which I believe will improve the chances for me to do something more precisely, or in my terms more acceptable. In addition to that, I gotta say I've become quite 2D oriented due to the CNC machine and laser cutter. So I've gotten myself a 3D printer as well, which I plan to use for more 3D optimized jobs. And if you're wondering, this is the Niva 3D printer that Dagoma kickstarted a while back. First off, I'm having electromagnetic interference when the laser is firing that sometimes causes the Arduino to either reset or completely freeze, which is an annoying problem as it controls the enabling of the laser, so it shuts off during cutting. One thing I could do is to remove the Arduino and the Nextion display and run full-on hardware buttons and knobs, which I'm pretty keen on to a certain degree. But then again, I'm thinking on adding an ESP8266 or an ESP32 for some extra features like MQTT and monitoring, some light controls, as I'll be needing something to display the water temperature anyhow. I just kinda hope that the rebuild will remove the interference by itself, as the electronics right now are not very good, but will be. Or that the ESP8266 or 32 will be less affected by it. Initially, I just wanted something silent for the smoke extraction, and that's why I didn't go with the traditional radial blower fan, but after a couple of tries, I must admit it's probably the best way to go. As explained in the introduction video, the very optimistic solution of using 2 toilet blower fans didn't cut it. So I leveled up and bought myself a 70 cm wide tangential fan to get an even smoke extraction across the whole bed, and the upside of it being very silent. But my first iteration of the fan mounting box beneath the machine just created too much turbulence, as the tangential fan is made for suction and airflow, not pressure. And my fan mounting box was not very smart. Next, I removed the poorly designed box, and to allow more airflow, I cut out the exhaust area in the back of the table in order to put 4 pipes going from here straight up to a styrofoam covered window to get the smoke outside. Which was okay I guess, but it still had that turbulencing audio because of too much resistance. And after we moved to this new workshop, there was luckily a radial fan already installed in the attic, so now my plan is to remove the tangential fan and make a single output connection instead. As now the tangential fan isn't doing anything except being in the way. The question now, however, is where to put the exhaust hole. On the side, in the back, on top, even below the cutting area? I don't know yet, I'll have to see what kind of design I'm going to aim for, but I would love to hear your suggestion on this. Of course, if you have an exhaust, you'll need an intake, and in most cases the intake needs to be positioned so that the air will flow across the whole cutting area. One thing I definitely want to consider is to make the intake area a bit flexible, so I can control the airflow if it should go underneath or above the cutting area when either cutting or engraving. as now I tend to leave the lid a bit open to clear the smoke faster when engraving. Not sure how I'm going to do it, but I'll have to consider it when designing, as that would be a great feature, wouldn't it? Alright, exhaust and intake is very important, but also where the smoke goes, it contaminates everything. Especially MDF, which is a fantastic material at creating heavy smoke that just makes everything so dirty. So I want to minimize that by encapsulating sensitive areas such as the laser tube, which almost all pre-built lasers have in some form. I can't do much about the linear rails getting a bit dirty from the smoke, but the better I make the airflow from the intake to the exhaust, the better or the less dirty they get over time, as some maintenance is always required anyways, like lubricating the rails, cleaning mirrors, the focus lens, and so on. With the bed the size of this one, rigidity is important, which this one surprisingly is, but I am going to change the 20 by 20 profiles with some 20 by 40 profiles instead for extra rigidity and some modularity that I'll come back to later. And one thing I already bought but just never come around to do is to run each of the 4 stepper motors on the bed with an individual stepper driver instead of running them off of one driver, as it causes this annoying high-pitched sound as I explained in part 4. I also want to move the stepper motors inside the machine instead of having them stick out below, as that will be changed and the reason for that will make sense later on. In terms of putting limit switches on the bed, I'm not sure. It would be cool, but I really don't think I need them as I rarely move it anyways, and I just level it by running all steppers down till they stop mechanically, and that's it. What do you think? It's not a priority, but is there another quick and dirty solution I haven't thought about? The cutting area should have been a honeycomb grid from the start, but I couldn't find one that fit my bed size, and buying 4 of them was just not an option at the time, as they are not very cheap. So I went for the old office lighting lamp grid pieces, which luckily someone sold online, which was pretty good, except the grid had a layer of paint on it, so every time the laser went past the grid, it contaminated the underside of my material with burn marks. I used that for a while, until I chose to laser cut my own grid out of acrylic, which I've used until now. And it works pretty well, especially with avoiding the burn marks underneath. However, it wasn't easy to install and hard to get every spike really level, plus the acrylic is a more expensive solution since I'll have to recut new ones after some time, as they won't last forever. That's why I want a more modular setup for the grid, so I can change grids depending on what I want to do, and I have seen a lot of great solutions from the laser people on the internet, and I definitely want to try some of their solutions as well. And by grid pieces, I'm talking about click-on modular pieces with magnets or something so I can change depending on what I'm cutting, either having my current acrylic solution, having it completely open, or making customized grid pieces for certain type of jobs, and maybe one with a fixed rotary tool axis so I can engrave or laser cut round objects. You get the picture. One thing that bugs me a lot is that when I'm cutting, all the small cut pieces fall down below and scatter all over the place. And as I can't really take the bed or grid out, I've unscrewed this left front plate, making it possible for me to get them. And then there is the binding of the lid that needs to be hammered shut, making the front plate sometimes fall off, which is quite annoying, and sometimes pretty embarrassing when showing off this laser to friends and visitors. But more about the lid coming up. I haven't come around to it yet, but originally I thought of making some low-profile drawers beneath the cutting area, so I could slide them out from the front and access those parts or just a regular cleanup. And now with the metal sheet bender, I actually think I can make something sturdy enough and also look the part. In theory, I will be able to access the area after the build because of the modular grip pieces that I talked about, but I just really like the idea of those low-profile drawers. I'm definitely gonna try it, and if it doesn't work, I'll just leave them as is. But what do you think about that? As some would say, bigger is better. But in my case, I'm not a very tall guy, and I have issues accessing the far reaches of my cutting area as the total height of my machine is, well, too tall basically, spanning from floor to top, a whopping 133 centimeters. So, my idea is to lower it. And I'm looking at these stainless steel tables it's standing on, and I'm not gonna cut them up. mainly because that would be a lot of work. Secondly, it would not be very accurate, like at all. And third, it would be a shame as they are pretty nice. And to be honest, I have no idea how I would even do it. The plan? Well, we've just got new members, Ivan and his son Thomas, and they have a lot of aluminum profiles laying around. So much, in fact, they're willing to sell some for a good price. And we're talking about profile sizes of 45 by 45 and 90 by 90. So I'm going to see if I can build a new lowered bottom frame for the laser out of those profiles. I don't know exactly how I will make it, but it needs to be functional and thought out. But as I don't know what I will or can get, I will have to wait for the design for that. Now, for the machine size in general, I'm already planning on so many changes that if I step back and think about it, I might as well go all in at this point and take some future upgrades into consideration. Therefore, I'm not only going to lower the machine, but also make it bigger. I'm aiming for a cutting area of around 900 by 1300 millimeters, or 35 by 51 inches, designing the machine backward from the bed size as seen here. To ensure I get the travel I need, as currently I'm not really utilizing the whole travel distance of my linear rails. The increase in size is also one of the reasons why I already planned on the sturdier 20 by 40 profiles for the bed. And by the way, this is just a mock-up drawing to help me visualize for now. The reason for this particular size is because when my current 50-watt laser tube dies or burns out, if it burns out, I will definitely want a more powerful one, and from what I've seen, they can get pretty darn long. And I want to be able to house it without having a stick-out box on the side of the machine like I've seen many people do, which is great because I planned on doing that myself when the time came, but also due to the wood sheets that I buy here are 1200 by 800 millimeters long, so I would be able to lay them directly into the machine without chopping them up first as I do now. Increasing the size of the machine's cutting area might affect the consistency of the cutting across the closest point to the laser tube and the furthest point by some factor. Especially with only a 50-watt laser tube, as the beam needs to go through a lot more air at the furthest point, causing a decrease in power. It's not that important when cutting, as I'll need to adjust the power accordingly, but when engraving something large, it might get very noticeable, also depending on the material. And I'm talking from my experience here. If that turns out to be a big problem in the end, I would consider moving the laser tube on top of the y-axis, meaning that the only loss in power would be over the x-axis travel distance, which should decrease it by some factor. Or of course, a more powerful laser tube in the future would also solve the issue to some extent. Any thoughts? Wow, this turned out to be way longer than planned, so I'm sorry for making this into two parts, but I really just wanted to update you guys on what's going on. Thanks for watching and listening to my non-stop babble, and stay tuned for more babble in the next one. If you'd like, follow us on G+ or Facebook as we post pictures from our Makerspace projects every week. Have a good one. Bye.